Hi, it's Mrs. Martello. We're going to look at 4.6, example 5. I'm on page 213. So in this example, we're going to use a real life situation here. It says online bidding for a purse increases by $5 for each bid after the initial $60 bid. So in this table, it represents what the cost of the purse is going to be. When there is one bid, the cost is $60, and then it goes up by $5 each time. Part A, we're going to write a function that represents the arithmetic sequence. We're going to graph it, and then we're going to find the winning, if the winning bid is 105, how many bids were there? All right, so let's do this one together. So on my paper, I copied down this information. You should probably write this down as well. And for part A, we're going to write a function that represents this arithmetic sequence. So let's use the formula. Remember, our formula is a sub n equals a sub 1 plus the quantity of n minus 1 times d. Let's find our numbers and we'll plug it in. Our a sub 1 is the first number in the pattern. That is 60. And our d is the common difference. So how do we get from one number to the next number in our sequence here? We add 5 each time. So that would be, if we look back at the word problem, the initial bid was $60 and it was $5 for each bid, so 60 and 5. Let's take those numbers and we're going to plug it in here. A sub n equals 60 plus the quantity of n minus 1 times 5. Let's simplify this equation. We're going to distribute the 5. A sub n equals 60 plus 5n minus 5. And then we'll combine our like terms, 60 minus 5. We get a sub n equals 5n plus 55. Now we could leave our answer like this, but it does say to write it as a function. So if you want, you can always rewrite this as a function here. Instead of a sub n, we can use f of n, so that would be our function notation, equals 5n plus 55. And that would be our function for our arithmetic sequence. Our next step now is we're going to graph the function. So we can do this on graph paper, or we can just do this right here in our notebook, and that's totally up to you, however you want to do it. I'm just going to do it in my notebook because it's going to be a little bit faster. So we're going to put our n's on the x-axis. And remember, these are our bid numbers. So we're going to have 0, 1, 2, 3, and 4. And then our y values are going to be our bid amounts, and those are our a sub n's. So this is our amount over here. And we want to get up to 75. So let's think about how I can do this here. Maybe 20, 40, 60, 80. I'll make this a little bit taller. That would be perfect. So this would be 10, 20, 30, 40, 50, 60, 70, and then here's our 80. And this is the a sub n axis. Okay, let's plot our points. So our first point is 160. The second point is 265. The third point is 370. And the fourth point is 475. And you should notice that the points are forming a line. They should be on the same line because this is a linear function. Our last step, it says that the winning bid is $105. How many bids were there? So you could approach this in two different ways. You could just take this table and keep it going. Keep adding the 5. So next would be 80, then 85, then 90, then 95, then 100, then 105. And then figure out what bid number would lead us to that 105. That would be one way. Or I can use this nice equation that I created here from part A and take this 105, remember that is the bid amount, so that's our a sub n value, and I could plug it in. So let's plug in, since we have a sub n, or since we wrote it as a function notation f of n, that's going to be the 105. we're gonna plug that in over here to this side. So our equation is gonna be 105 equals 5n plus 55. And let's solve for n. We're gonna subtract 55 from both sides. This would be 50 equals 5n, and then divide both sides by 5. I get 10 equals n. So how many bids were there? There were 10 bids. That's an example of a real world arithmetic sequence problem.